Square roots. Looking at a square root, the first thing you have to do is identify the different parts of it. If you have the square root of 36, this symbol is called the radical symbol, and the number inside the 36 is called the radicand. And the answer to this is 36 is a perfect square because 6 times 6 is 36, so the square root of 36 equals 36. Now let's do some practice problems. Look at question number 1. Plus or minus the square root of 49. That plus or minus is very important, and it's going to make your answer different. If you see plus or minus in a problem, it means positive square root of 49 and negative square root of 49. And to make that simpler, they put the plus and minus together to get plus and minus, or positive and negative, the square root of 49. So that means we want the positive answer and the negative answer. So if you look at the radicand 49 and you find that on your table or on your perfect squares pictures that you colored, you would see that the square root of 49 is 7. But because we have the plus or minus, we simply have to add plus or minus in front of the answer. So the answer would be plus or minus 7. So that we have the positive 7 and the negative 7. Let's look at problem number 2. The square root of 4. This one, we're just looking for the positive square root of 4 because we don't have the plus or minus. And if you look at your table or your squares pictures, you would know that the square root of 2, I'm sorry, I just gave you the answer. The square root of 4 is 2, and it's because 2 times 2 equals 4. Let's look at question 3. Negative square root of 121 over 81. Because we have the negative on the outside, we're going to have it in our final answer. And then if you look at the two numbers in the fraction, 121 is a perfect square, 81 is a perfect square. So you're simply going to find the answer by finding those perfect squares, and the answer would be negative 11 over 9. Here's question number 4. This one is special because we have the negative on the inside of the radical. And you might think that the answer is 9, but if you think 9 times 9 doesn't give me negative 81, and if maybe you think it's negative 9, negative 9 times negative 9 also doesn't give us negative 81. So right now, because we don't know about imaginary numbers yet, your answer is going to be no real solution. Because there is no real solution, because the solution is imaginary. Let's look at question number 5. Although this one is a decimal, you can still solve it. So looking at it, we have 0.49. 49 is a perfect square, and we have a decimal involved. But we're going to do the same thing and get the answer to be 0.7. Because 0.7 times 0.7 is 0.49. Now let's look at equations with exponents. Let's star this section because it's very important. And let's look at example 1. We have the square root of x equals 7. So normally in an equation, we have to do the inverse operation. Well, the operation that's occurring here is this square root. So we have to think, what is the inverse operation of taking the square root of something? If you take the square root of something, the opposite of that would be squaring. So to solve this problem, we're going to rewrite the original problem so we can see all of our work. And then we have to square both sides. And squaring something means we're going to have the exponent 2. So if we have to square both sides, the first thing I'm going to do is put parentheses around each side and put a little exponent too. Because we've done the inverse operation, we can now cancel something out. So the radical symbol and the exponent 2 cancel each other out. So once I've done that, I have x equals, and I know 7 times 7 is 49. And I can check my answer because if I go back up to the original problem, I have the square root of x, which I think is 49, equals 7. And is that true? Yes. So let's move on to example number 2. Go ahead and try to do this one by yourself. So I'm going to rewrite the problem. I think. Nope, I'm not going to rewrite it. I'm going to put the squared on both sides. The square root is canceled out by the exponent 2, and I'm left with m equals 100. And I could substitute it in to the m and have the square root of 100 equals 10, and I know my answer is correct. Here is the next type of examples. Go ahead and copy example 3. Example 3 is x squared equals 64. So for these examples, we have the operation of squaring. So the inverse operation of just squaring, not a squaring. The inverse operation of squaring is square rooting. So I'm going to rewrite the problem, and now I have to take the square root of both sides. To take the square root of both sides, you're going to use the square root symbol or the radical symbol. So I'm going to put the radical symbol on both sides. And just like before, a radical cancels out the exponent 2. And I'm left with x on that side. And I know that the square root of 64 is 8. So the answer is x equals positive or negative 8 in these cases, because 8 times 8 is 64, but also x could be negative 8, because negative 8 times negative 8 also equals 64. So be careful with these examples because you have to include the plus or minus sign. See if you can do example 4 by yourself. This is going to be our last example. We have x squared equals 144. So I'm going to rewrite the problem on this one so I can make sure I can see all my work. Record. So for this one, we have x squared equals 144. The opposite of squaring is taking the square root of something. So you would put a radical on each side, and the radical symbol always cancels out an exponent of 2. And you're left with x equals, and the square root of 144 is 12. But we have to make sure we put plus or minus 12 because positive 12 times positive 12 is 144, and negative 12 times negative 12 is 144 also. So you would have x equals plus or minus 12.